Okay, so this is number 2 from the sheet that we started, and actually had 2 solutions for this problem yesterday, which was kind of interesting. But again, it started with the picture. Okay, and so you've got this grandfather clock, and then you've got the pendulum in the middle that kind of swings from side to side. And that pendulum has a length of 94.5 centimeters long. Okay, so basically, you've got this pendulum, okay, should hang straight down. Oh, that's not drawing straight. Hang straight down. And then it just swings back and forth, okay? And so the question is, if it swings a total of 10 degrees, right? So basically, it's going to swing out and then swing back like a pendulum would, right? It's going to come out here, it's going to swing, and then it's going to swing out this way, right? And that total angle measurement is going to be 10 degrees, okay? And so we could do this one of 2 ways, but ultimately what they want to know is how wide does the casing need to be in order to contain this motion. Okay, so you're basically looking for this from side to side, the blue piece. Okay, so I saw a couple things yesterday. I'm just going to redraw this. After you've drawn the situation, you can kind of maybe just redraw the triangles. I saw 2 situations yesterday. First one, which is what came more naturally to me, was this. I was going to create a right angle triangle. Up top was going to be 5 degrees because you're splitting that motion in half. And then the hypotenuse here was 94.5. And what I was going to look for was x. And so what I could have done is stood at the angle 5 degrees, looked across, and saw opposite, right? So I was going to do sine law, or not sine law, sorry, SOHCAHTOA, but the sine version of it. So I'm going to pick sine of 5 degrees is going to equal opposite x over 94.5. Okay, and then to get x by itself, you just multiply both sides by 94.5. And so you get 94.5 sine 5. And so x you would have seen to be something like 8.2, but we'll see. 94.5 sine 5 was 8.23. Okay, and then you'll remember this was just 1/2 of the motion, right? So there's your kind of like equilibrium point where the pendulum kind of sits. If it wasn't moving, it actually would have swung back the other direction, right? Another x value. You would have 10 degrees at the top, and so the total width would have been 2x. Okay, and so total width would have been equal to 8.23 times 2, which would have been 16.46 or something like that, right? I think was the answer. Okay. And then you can say, therefore, the width of the grandfather clock would be 16.46 centimeters. Okay, so that's one way. I also saw people set it up just like that, just exactly what you would have seen there, where you went like this. Okay, would have swung, and then you would have had your 10 degrees at the top, and then you would have 94.5, 94.5, and then this would have been x. Okay, and what I saw people do is use cosine law. So what I said, x squared is going to equal, if we had to label this, even if you want to label it a actually, just for simplicity's sake. You could say this is A, that would have been angle A, B, side length B, and C, side length C. And so what I saw somebody do yesterday would have been A squared is going to equal B squared plus C squared minus 2BC cosine A. Okay? And so you can input all that information and solve for A. Okay? Where A is the thing you want to know, so A squared. B squared would have been the 94.5 squared plus 94.5 squared minus 2 times 94.5 and then cosine of 10. And if you typed all that in, you would have gotten 16.46 centimeters. Okay? So 2 solutions. Again, it comes down to how you set up the problems, and then you just use some of the stuff that we've learned in this class to pivot and solve for ultimately the thing you want.